Okay, so I just want to give that. So it'll still record my voice, but I'm not recording the wall or anything. So at the top level, in fact, maybe I'll do it in real time here, just because. Okay, so at the top level, you're talking about something that sort of has security and privacy. Okay, so at a top level dichotomy, I can imagine many papers having. Oh, you guys can't see that. Many papers having been done at that top level. Okay, but if the two ways I described of trying to do your survey paper, one is to think of varying dimensions, right, and the other is to think of a sort of dichotomy or a tree structure where you break it down, right. So if the top level is security and privacy, I can be looking at this as a tree, because I come back and look at this dimension, but as a tree, the next layer could be different than that survey paper, right? So if that survey paper just said, well, here's security and here's privacy, they didn't really break the world up into very much. But inside of privacy, we can look at different parts of privacy. Privacy of the transaction, privacy of the information taking part of the transaction, privacy of the addresses and personal identifiable information, but not of the actual transaction, right? So there's a bunch of different things. So you can have underneath it a new breakdown of that dimension, different from what that paper did, right? Even if the top level is still security and privacy, because now you're providing a different way of looking at security and privacy for the same problem, okay? A slightly different way of doing that would be to view security and privacy. So, and you can do the same thing on security. Yes, you could take the three, CAI or CIA or whatever, right? I like to call them CAI just because otherwise it has a weird implication. But the CAI parts, right? You could talk about them that way, right? And lots of people have done that. We did in our blockchain paper, right? But you could also look at security from a very different point of view, which is not the security of the system itself, but the security the system provides, right? So you could look at the functional security. What do I get from a security point of view by using blockchain, right? So that it's all distributed. It's not my software. So again, you can take the same high-level description and start breaking it down differently. I could also look at security and privacy in your case as a dimension, right? So there's levels of security, right? There's levels of privacy. So if I view this as a dimension, then I can start putting the papers literally, right? So if I think of it as here's security and privacy, right? Here's privacy, here's security. I could actually do a drawing of the papers, and I could put some that have a little bit of privacy and a lot of security up here. I could, put the number 3 over here for this paper, 6, 8. I can have this diagram of where do these different papers show off in this trade-off between security and privacy, right? And if they've not done that, then that gives you a way of organizing the information that's different from what they've done, right? And then readers can look at this and say, oh, look, I'm looking for something that's got high privacy, and I'm not so worried about security, so I'm looking at this group of papers. Or I'm looking for things that have high security, and I could give squat about things, so I'm looking at stuff that's up here, right? I don't really care what's going on in privacy, right? So different ways that it provides value to the reader by breaking it up differently. Does that give you a helpful hint?
Yeah.
Okay. And that's going to be true for, so what's your problem in your software?
So mine was exploiting vulnerabilities. And I realized the biggest problem I have is I don't actually know what techniques are available to do this. So yesterday I came to a different idea. I'm just going to go in the direction of categorizing what techniques are available. And also I have to cite the research efforts I've done for each technique. Essentially moving papers.
Okay. Yeah, but an enumeration style is really pretty weak, right? It's like, okay, here's the papers. It's like chronological. Here's the order they went in. From a survey point of view, that doesn't really help people organize, right? That's just a giant list, okay? But if you could take the attack approaches and you break them up into, first, high-level things have been, right, well, okay, here's the OS, right? Obviously, the same attack can be applied across different OSs, but I could have something where at the top I have, right, OS, and then I break them down, I put attacks here, okay? But the attacks could also be broken down differently. I could be, what's my objective? So what's the goal, right? So if the goal is to become a bot versus info versus denial, right? That's another way of dichotomizing how the attacks are put together, depending on what's the goal of the attacker, right? So again, looking at them from a different point of view gives your reader now more value. If I'm really only interested in things that are about how do I actually steal information from your system, then all the attacks will be over here, and I will understand, and I can compare and contrast them with the same objective.
Is it back going to the same enumeration?
Well, so if I just enumerate them, that's really just saying 1, 2, 3, 4, 5, right?
It doesn't have to provide like a new technique for results problem, right?
So a new technique, right? So if there's a survey that already broke them down this way, then your and the survey's recent, then you're not going to help the reader, right?
The reason I'm saying that, sorry,
Huh.
so, my survey goes on the interest floating effect on the IC. So that tax is still exists from like few published paper, how to resolve it, how to mitigate it, that still exists and they haven't really prevented.
Mm-hmm.
So my story is to just talk about the attack and talk about the existing papers and probably maybe while I'm working on that, but I'm not working on it, so yeah, really,
Mm-hmm.
but maybe just provide more information that hasn't been published yet about how to resolve this problem.
So you can provide some, but
Our direction maybe.
the goal of a good survey paper, though, especially with a survey paper with as many papers as you have to have in this, right? So you have a lot of papers. You're trying to help the reader organize that literature in a way that they can now say, okay, I've learned something about how to group them together, right? So if you just say, here's a enumerated list. So you did that in your survey, in assignment 2, where it's like, here's this bibliography with a bunch of numbers, right? Without some organization, people are going to say, well, I can already go to Google Scholar and just look at papers, right? What am I really getting at this? You have to give me a story to understand your survey in a way that helps me digest this information. Not just here's a list of references with all the things associated with it. So maybe you can, and yours can be, the organization might be, how many papers are there? There's, 30, 40 papers that you say are out there. How many, or is it 4 or 5? Okay, right. So if you go through those 15, literally one of the ways you can do some of this is if you put together, so if you put together those 7 items that I mentioned, right? So those 7 items assume you already have some level of dichotomy, right? If you don't yet have some dichotomy, I guess I didn't spend enough time talking about how to figure out what that is. You might take your short notes about these papers, put them on a bunch of little Post-it notes or bigger Post-it notes, depending how big they are, and literally start trying to put them up on the wall or just do them as pieces of paper on your desk and start trying to figure out a clustering. Well, if I do this, I can put 4 here, 2 here, 3 here, or whatever, right? If you can get them so that each group, by the time you're done, only has 2 or 3, then you can find, and it might seem you're inventing, a hierarchy that says, okay, these 2 piles have 3 each, but they share this one thing in common. So if I have 2 groups of 3, and I can connect them through a hierarchy, right? Now I have something here that's got a group of 6. I can take some other ones, right, and find, and maybe it's now 3 because they're actually not as related, and then I can connect them up, right? And then I find some way to connect these, and now I have 15 papers in a hierarchy, right? So it's finding something in the papers that they share, or something that they don't share, right? So that you can say they're different because of this, right? And try to put them together to make that story. Make sense? Do you think you can do that? Okay. So does anyone actually have a positive story now? We've had to talk about some difficulty. We'll come back and talk some more about the positive, the people who are sort of. Does anyone actually have something they found, they thought it was a good way of breaking up their world?
Working on segmentation of medical literature, and it looks like the supervised, semi-supervised, supervised means of conducting segmentation or segmenting literature looks like it's actually categorical categories.
Not getting to say. So that's a high level. So in fact, one way of looking at that one, so if you only have 3 and you only have 1 layer, better not to view it as a hierarchy, because it's not a hierarchy, it's just like a bush, right? 3. Right? But if in your case, you could actually look at that one as a single dimension, and then, in fact, if you work hard, I'll bet you can find that other dimension, where here I have sort of the level of supervision, right? From none to full, right? And then you can place paper. Because when they say semi-supervised, it's a question of, well, how much supervision do they get? Do they get one example labeled and they got to find 1,000 to go with it, or do they get 50 data, right? So you can sort of put them along this axis pretty easily. And then see if you can find some other axis along here to separate them out, right? And so it might be like the modality, not very deep, but the size or the amount of data, right? So some other dimensions are pretty easy to add by just looking at what the paper has in it. And then you can have a broader dimensionality reduction of your...
Under those three categories, I like that idea because it is more continuum than three different categories. The problem with medical segmentation is the data sets tend to be very small, so you put a lot of work into unsupervised segmentation.
Yep.
Large data sets and big use of data sets, and then there's data augmentation as well. So
Right. So this might be the level of augmentation, right? Now you get 2 dimensions, and then you can. So it's surprising how many people find it really useful to then see paper numbers, right, laid out in this 2D spot, right? It's like you get to look for what are the papers. My problem has this level of supervision, this much augmentation. What's the most related kind of thing I can go find, right? It helps them visualize where things are, but also gives them a way of understanding how the other papers are related to it. So
the data sets are ridiculously small, so maybe even
a third dimension is like size, right?
Right.
But yeah, so then you get the fun of doing a 3D drawing. But for this, right, just for the drawings I'm hoping you'll have for this week, right, it's fine if there's stick figures like this, right? And you don't even have to have all the papers in the right place. It's really, here's how I'm breaking them up. I will figure out where they belong in this. You're telling me, here's how I'm telling the story, not, you're not finishing the story yet. I just want to see if that makes sense. Anyone else, somebody else had one to share? Your idea? Was it?
Yeah. So Facebook.
Yeah.
So I'm looking at code similarity and malware similarity to try to classify malware samples. So the way
The
way I'm going to try to break it up is I looked at a lot of papers and a lot of different authors proposed different ways to classify malware as a specific category or family based off of its standard features. So one way was using like fuzzy hashing is one technique. Another technique was using dependency analysis, so dependencies, like looking at which libraries get invoked and which API calls are made. Another way was looking at metadata of the compiled binary, like compiled timestamps and the size of the code section, size of data, different strings. So I've kind of classified into these 3 techniques, and I'm probably about half a dozen to a dozen papers in each category. I don't know if I can refine that further. Whether like fuzzy hashing, there's different algorithms for it. Different types of ways of doing dependency analysis, whether it be looking at operating system calls or libraries, and then metadata. What was interesting about doing this is I did find some interesting gaps that weren't addressed in the literature, like using different compilers can drastically change any hashing, but it's the same exact malware, just compiled it with a different compiler. No, that doesn't work. If you change operating systems, your API calls are going to be different. Again, compiler variations can change metadata. So I found it interesting that compiler modifications weren't really addressed in any of the literature I found. So I don't know if I'll address that as a spin-off or if I should include that in the survey.
Oh, you should definitely include it in the survey, because if your survey points to like here's a gap, right? It's sort of interesting, right? And so that makes it a very interesting part. Now, you could also look at especially if you have a very flat hierarchy. Another common technique is to sort of say, well, so let's take the hashing, right? So fuzzy hashing is traditionally applied just to the raw data. But what happens if I did fuzzy hashing to the API calls, right? Is that actually a useful way of making the API calls more generic? Which is, even if I change machines, the sequence of things I do might still look similar, right? So you don't have to answer those. So this becomes part of the discussion, where it's like, well, maybe we could be applying these techniques here and whatever, right? And that's maybe how we make it more compiler independent, is if we did this, which was designed to make it more independent of this, maybe we could apply those, right? So that kind of discussion that shows up after you have the space becomes pretty useful.
Find some sort of abstraction or normalization.
Yeah. Right. So here you've given them names. The other way of looking at them might be to look at what's the sort of core data, which is being independent of the representation, right, which is what this is, right? Trying to be independent of, or trying to capture the representation, trying to capture the sequence, and trying to capture, I'm not sure what the metadata is capturing. Metadata is all over the place. But, so capturing non-code data, right? So then, even though you get to them, you can say, well, we're going to call them hashing and flow or whatever. But that actually, once you put that high-level categories, maybe there's some other ways of capturing that information that isn't based on hashing. For example, I know there's some papers in that space that are also looking at using, for example, n-grams as a way of capturing localized content information about the malware that isn't as general as hashing, but then allows you to use those as features in some other, like machine learning-based representations or whatever. Right?
Yeah, yeah, we saw a lot of n-gram approaches to this.
Right. Yeah. So which is different than hashing, right?
Right.
But then you've put them together underneath the capturing, structural information or something like that. And you can break them up into added categories. Okay. Cool. Anyone else want to chat about theirs? There's another hand over there. Go ahead. Okay. No, you can. Can everyone hear her? Yeah.
We are doing it, team work, so we come up with, we kind of, our interest is goes two different ways, so we came up with an idea to be in the middle, and it's about connected vehicles, specific to connected car. And when we start our search, first we started our search as security of connected vehicles, and it was really, really broad. Like there was like 17,000 research, and it can go so many different ways. So our biggest challenge was to narrow it down. And as we are looking cyber, physical security, we focused on narrow it down to security threats via mobile devices that connects to the internet.
Yeah, and that's how we kind of narrowed it down to a more usable set of articles and documents. So we're trying to cover is we had a broader for connected cars, we're looking at self-driving cars, driverless cars, vehicles, I should say, trucks and cars. But then we're starting to narrow it down, looking at attacks, looking at vulnerabilities, and then trying to get a funnel where we get something that could be visible in real time. And it seemed like the smart devices, mobile devices there wasn't a lot of research, there was a lot of experiments that were done, a lot of attacks, vulnerabilities. So it seemed like a likely area to focus on. And for our classification, we're trying to break that down in those areas. So we're starting with all the components that are available. So whether it's inside the car, networks in the car, outside the car, the cloud-based stuff, whether it's the cloud computing, the vehicle, and the vehicle ad hoc network. We're looking at all these different attack points or services. Just trying to narrow down from there what's actually going on the device side.
Yeah, so it is a natural thing. You'll find many security papers do look at it by basically enumerating the attack surface and then saying these attacks attack this, these attacks attack this, right? So that's a natural way to get the sort of, again, one level of this. Okay, so, and there's actually another style of this which I didn't mention, but maybe it'll be helpful for you guys, and I think it will actually apply here, which is a little bit like this, except here this is actually a real continuum, right? So we went from unsupervised to supervised learning, right, or whatever. Right? So I can take something and I can do it with these blocks. Where let's say I looked at, here I'm looking at the information, well, so in your case, I'll actually go to yours. So here we have different surfaces, S1, S2, S3, S4. So, this might be the wireless interface, this might be the CAN bus, this might be, right, whatever the enumeration is. Then you can look at various types of attack dimensions like here, where it can be like physical connection, wireless connection, right? So you choose some dimensionality here, and now it's actually not quite a continuum, it's really just a grid, right? I can ask, what goes this kind of attack against this part of the system, right? So it still gives you that same visual layout of, here's a couple of things, and then you can look and say, oh look, no one's looking at wirelessly attacking the CAN bus. Right. Well, that might be because the CAN bus is a physical wire, so it's really hard to wirelessly attack it. Until cars actually, and some now actually have a wireless connection to their CAN bus, so they can talk to like the OnStar in their car, and remotely send diagnostics. Which means, despite the fact that you're talking CAN bus, there is a wireless connection in the car that's connected to it. So indirectly, I can attack it by going through attacking that OnStar connection and tapping into it. I'm just making this up. I'm not sure that those are meaningful for where you're going, but this idea gives you a way of, rather than just have, no, it's way better to have an enumeration of categories and have papers in every category than have an enumeration of papers, right? But if you can have the enumeration broken down so people get more out of it than just it's in this category. And since many papers address more than one thing, by having this sort of two-dimensional version of it, you can put the same paper in a couple of places and get a feel for it. Make sense?
So let's go back to the very beginning when we started with the security and privacy.
Mhm.
How can you just connect with each other and have to do everything?
Well, so he started with security and privacy, which there are papers looking at security and privacy. What I'm saying is the next layer of that survey, if you make that layer different, your survey is different, even if your top layer was security and privacy, right? So if you can do something that trades off how you look at security or how you look at privacy differently than they did, then you get something that's different. Even if the top level is survey on the security and privacy of blockchain, right? The title could almost be the same, but you're looking at security and privacy differently, right? Privacy and security are actually, in my view, they're two sides of the same coin. If it's my data, it's privacy, right? If it's somebody else's data, it's about system security, right? If I don't have security, I can't have privacy, right? So there's a bunch of trade-offs there. But in the blockchain space, there's this whole anonymity, which to me isn't the same as privacy, right? It is. It's identity privacy in a piece of the transaction. So there's a whole bunch of dimensions. So I'm sure Mark can find a way, this is Mark, right? Yeah. To split that up differently than the existing papers, right? Because there's so many ways of looking at security and privacy, right? You can look at them as dimensions and just change the labels out in terms of how are they protecting information, or what information is protected, or what is shared and what's available, who gets access to what information. There's a lot of ways of breaking that down. And then maybe even looking at it in terms of, say, provable privacy versus practical privacy, right? So sometimes you can't even prove it's private, but you've done a good job of protecting it. That's why I drew it as a dimension, right, in that one form where I looked at it. Because I can say, look, this information is not available unless somebody hacks inside the system, and then it becomes available. So what level of privacy is that? Well, that's not the same as the level of privacy if I've never ever stored the information. If I've never stored it, there's absolutely no way to violate the privacy. It's not there, right? But it has less utility then, so there's a trade-off. I'm not sure what your question was, so I don't know if I've addressed it yet, or should I keep rambling? Okay. Anybody else want to talk about yours?
Yeah, sure. First question, how long did you consider survey paper?
So to me, an old paper is a paper for which there's at least 40 more relevant papers missing from it. Okay, I don't define it in time. So if the area is growing very slowly, it might be old, in 10 years. And if the area is growing really fast, right, it might be old in a year, right? If the field advanced very quickly. So somebody's doing adversarials, right? So adversarials, that space is advancing very, very fast. And there's one or two surveys on adversarials already, but one of them that, it's an archive and they keep updating it. But when 70 or 80 papers come out every 2 months on that topic, which is what I see, because I see all the papers that come out in that space, right? You're going to have a survey that's old really fast, right, in terms of the space, because people have added so much more to the space. So in electric, you're doing electric vehicle stuff or batteries?
We're doing, yeah.
Lithium, like battery? So I don't know how fast that space changes. Right?
Well, it's a particular type, so we're doing hysteresis models for,
Okay.
and there was a survey paper done that I think it was in the last week similar to what I'm doing. However, just thinking through that, thinking about maybe readjusting it to be more of a focus on rather than how they're created, sort of operator based is how the survey paper does it. But when you think about batteries, you think about that it's not really rate dependent on the current going into the battery versus so rate dependent is not rate. So think about maybe breaking it up that way.
right, breaking it up differently, right? So then even if you cover the same papers, right, then your view of the papers may be way more interesting to somebody who's trying to build on the work or who's trying to build battery controls, right? That's perfectly fine. Even if you cover 2/3 of the same papers from a completely different point of view, that's still valuable to the reader.
Yeah, because we're also looking at other types of models. Because there's been a lot of research done, and okay, it starts with this basic model, but oh, let's tweak it just a little bit to try and make it work a little bit better. So it's
And so, and if you view it as more than one dimension, right? So there might be like whatever dimension your primary rate. Then of course you have the what kinds of batteries does this really apply to? Because you change the chemistry, the batteries may or may not apply. You might have a dimension which is, what's its TRL level, technical readiness level. How close to this is actually being usable in the field is another sometimes very easy to mention, right? This has been simulated in MATLAB, right? So that's TRL2. There's actually, if you Google TRL, these are used in government contracts all the time. We talk about technical readiness levels, right? You can talk about something that's been bench tested. So they put it together with one battery in a lab, and it sort of works, right? It's been tested on 50 batteries in the lab, so next scale of testing, right? It's been tested out in the field on a production level, right? And it's in production, right? So you get different levels of how mature is the technology. That's, again, another very often easy dimension to add if you're trying to find a way to expand the space, which is you really look at the paper and it's like, well, where is it? How far has it gone along? And depending on who your target audience is for your paper, that can be extremely useful because lots of people will be like, yeah, so it works in the lab, but I need something I can have in the field in 6 months. That's too big a gap. I can't fill it. I need something that's closer. Or all the stuff that's out in the field isn't good enough. I want something from the lab because I want to go a new direction and really try and push it. So.
the majority of the papers around are actuators, hydroelectric actuators, so there's some history of batteries, but to do survey paper, I believe survey papers are more specifically related to batteries.
Okay. So I've definitely seen lots of blog posts and papers on hysteresis and batteries and various claims that they do or do not have memory and all this other hysteresis stuff, right? So I'm sure you can find some different way of looking at it if there's not a good survey. So.
Yeah, and that's another example of our survey paper is going to be like to compare those different models and try to see which one is like reliable and suitable for battery.
Mm-hmm.
Is what we want for the subject is we want to find a model to describe the hysteresis in the battery. So even though some models like very complicated and fancy, but it's like take time to compute and cost a lot. So we want easy and accurate. And yeah,
The one that can be implemented online.
yes.
The big thing is that battery management system,
It's got to be, yeah, it's got to be online. You can't use 40 watts to compute it either, right? So it's got to be online and cheap enough. So that makes sense. So the one other dimension which I didn't mention is but may be worthwhile for some people who haven't talked yet, right? Or maybe even for some of the ones that are out there. Because when you were talking about this, right, it also is very important who you decide your audience for your survey paper is. So a battery hysteresis survey paper aimed at a random hacker like me, right, would be very different than somebody aimed at professionals who are trying to do hysteresis for electrical vehicle control for main manufacturers, right? So you can take let's say there is one for manufacturers, taking the same concepts and turning it into a survey paper aimed at a more average audience is another way of actually making lots of value. So again, in the security space, taking the survey of blockchain papers that might be aimed at experts who understand CAI and crypto and all this other stuff, and aiming it for the average citizen or the average technologist at a company who doesn't really understand all of that, right, can significantly change the survey paper. Because one's talking about how do I make it understandable to the practical person. I mean, we're not talking about making it understandable to your mother, right, unless your mother's a techie, right? You're not going to get blockchain for the average household, but blockchain for the average CTO, right, might actually be a very different paper than blockchain for blockchain researchers, right? Right, sort of like a gentle introduction to, right? As opposed to an expert's introduction to. Anyone else want to chat about theirs? Instead of making everyone do it, we'll just go through volunteers, good or bad, difficult or whatever. So we can talk about yours, Tina.
I'm not sure I'm doing my right anymore. I'm doing a survey on security compliance in the cloud.
Mm-hmm.
And I found a lot of papers and I was able to categorize them very well. But am I supposed to have some kind of solution or my own research to add to the paper?
No.
What I'm identifying is all the gaps I see in the current research, and so I probably have like a dozen potential research paper ideas, and I was
Okay.
just going to list that in my like summary. Here's all the things I think is missing in the current environment.
Okay, so tell us a little bit about your categorization.
I found about the papers split not quite 50, 60-40 on what I term policy versus security. So the papers on policy have subcategories of framework, compliance, governance architectures, and the ones in framework, they talk about the current standards like NIST and ISO, and they identify that they weren't really built for cloud, and they are missing a lot of important material for cloud, and everybody's solution that writes those kind of papers is to develop their own framework. So NIST and ISO don't have it right, so here's my new framework.
Mm-hmm.
And so that's actually like one of my possible research papers is does the world really need another framework model?
Mm-hmm.
I don't know if there's any
A framework for frameworks, right?
only one paper I identified actually proposed an extension to the current ISO standard, which I think is valuable versus we just created another framework so we could get published. On the security side, they talk about threats, and a lot of the papers regurgitate all the common NIST security issues in the cloud, and I even wrote down, and then they claim, and here's the mitigation to solve this problem. I even wrote them down because it's hysterical, and unfortunately most of the papers are this way. Virtual machine security, change the default config to enhance security.
Okay.
That's the mitigation published in high-ranking journals. And so on the security side
Well,
of the house,
but the statement is probably true, but okay.
lacking any useful detail whatsoever, and so I probably have more potential research ideas on security about just technical solutions. Like I could totally rewrite that guy's paper and list exactly which parameters on a VM template should be fixed to implement, to harden that one box in the giant compliance framework.
Well, they're practicing security through obscurity. They don't want you to know what to fix because then you'll tell everyone and they'll know what to attack. I'm just joking.
That's okay the way I'm going.
Yes, that's so. Again, it sounds so like for the policy side, you actually had a hierarchy, right? You had a breakdown and then more underneath it, whatever. That helps break up lots of papers in a meaningful way that people could sort of traverse and get a feel for what's going on, right? So the answer to this is it's actually, as long as you found something that helps categorize the papers, you've done fine. So in your thesis, you'll have a chapter that's background research, which is a kind of survey. This may be more detailed than that and may be different than that. By the time you get there, so don't worry about having your own research. The survey paper's goal is not to solve the problems. If it was, it wouldn't be a survey, it would be a research paper, right? If the goal is to survey, the ideal thing is to identify gaps, problems that people can work on, right? Because then other students or other researchers can look at it and say, oh yeah, there's a gap. Look, I know how to fill that. I can apply my tool in that gap and fill it. Right? So that's the kind of thing you're looking for in your survey paper. That's if you don't get there, if you just really give people a way of completely understanding it, you then don't identify any gaps, it's okay. It's just not as likely to be as cited or as useful. Okay. Now, and I didn't say this, but your survey paper can also trash other papers. Do it politically, right? It's like, here's a bunch of papers that don't quite solve the security problem, right? Or partially, but you could call that, right? So partial solutions to the security problem, or steps towards, right? Literally, in fact, the one I just did, I think we actually called a bunch of our papers towards whatever, because we know we didn't solve this problem. We're just making some first steps with it. So, you can have that entire section towards cloud security, and then talk about all the gaps that are left or whatever. That's fine. Can you what? Can you include some research? Yes, it's okay. You're going to do another research paper, so it's sort of funny if you include, I'd say more than about a page of your own research, ACM surveys will send it back saying this is no longer a survey, this is a research paper with a very long related work section, which is not appropriate because they don't want it to be about your work. They will also send it back if I did a survey that was too much about my work and not about the broader field. They'll also send it back as being too narrowly focused on my own work. The AAAI paper that I gave as an example was the same way. They actually said, although I thought it was funny, I think you had to cite at least 3 other people's work. It's like, yeah, that's not very broad. I think it'll go a little bit broader than that and add some more. But if you want to include it because you want to send this off and you really only have a little bit, now, and I'll take that back. It is actually quite common for survey papers to include novel research that is focused on comparing or analyzing the techniques they've described, as opposed to proposing a new technique, right? So if the first thing you want to do is like, well, we're going to compare these 5, that is new research, but it's research that's quite compelling in a survey paper because you're taking things people haven't compared and you're comparing them. It's just the 4 or 5 pages describing our new hysteresis algorithm doesn't quite fit in the story, so, at least for the way we're looking at them.
Questions that are off topic. Can I copy a diagram from another paper if I reference that I'm taking from?
So yes and no. So diagrams, oddly enough, are more aggressively copyright protected than the text, despite the fact that text is easier. But so you can, in this class, you definitely, absolutely you can. So you can have a figure and then you say in the caption, it should be in the caption, you say figure 1 adapted from whatever, which I think I actually gave an example in the paper I did. I adapted one of his figures. I didn't actually take it because it was boring. I redrew it and colored it and some more stuff, but it was still his concept. So you can. When you go to actually publish, if I want to include figures from other people's work, then I actually have to go get the permission of the original publisher, which sometimes they get really annoyed with. So it's not uncommon for us to actually submit papers where our figures are borrowed, and then while it's undergoing review, we redo them so that we don't have to include them.
And second question, almost all the published papers are with multiple authors.
Yes.
And so everything is, we researched this and we did that.
Yeah.
And as a PhD student, we obviously want to get published. Are we to put our advisor as the second author on our papers?
Who is an author? It's a good question. I would put your advisor on the paper if he or she contributes substantially to the paper. That doesn't mean they wrote paper, right? If you have weekly meetings with them and you discuss ideas, that can be very valuable. Like one of my first papers, I put my advisors, he's like, but you wrote the entire paper. You didn't, I didn't write anything. You didn't, it's like, but we talked and you gave me the insights that I needed to make the paper happen, so I feel you're an author. At which point you said, okay, then I'm an author, right? That's up to you to decide when your advisor is, right? If your advisor says, I have no idea what you're talking about and I didn't write anything, but I want my name on it, if they're paying the bills, there's still some pressure there, but pragmatically, they're not. So if they push you on that, it's like, well, then can you give me some feedback on the paper? Can you really be involved, right? In that AAAI paper I gave out, my students didn't get to see it until the day before it was due, because I didn't start writing until the day before it was due, but it was all based on work we had done together, right? So even though I wrote it, it was a we paper. Even if I write a single author paper, it is still quite common in single author papers for people to use what's called the royal we, right? The we is, as we see here, isn't about multiple authors, it's about me and the reader, right? On the other hand, if I say, we did this, then it seems a little bit weird. So the we can show up in a sense, even in a single author paper, when it's about me and the reader in the context, but not the single author. But my recommendation is do get your advisor involved, because he or she has probably done this more than once and will give you valuable insights in the paper, right, that you might not otherwise have had. Even if they're just a reader and they say, I have no idea what you're talking about in section 4, right, it just seems a jumble. That's making your paper better, right? And you should, now, does it rise to the level of authorship? Well, that depends on how meaningful those comments are and how you're feeling about it, right? But authorship, so as long as you're first author, almost no one who is looking at you for a promotion, for a job hire, or anything else will say, what are all these other people doing on here, right? If you're the third author in a list of 8, they really wonder what's going on, right? How much did you contribute? But the first author normally gets to be the first author, right? And
When you're starting out, when you're preparing your way fast, like somebody like you on my paper, if people are going to search your name, maybe like, oh, well, it's got something new.
so yes, and so to be honest, when I told my advisor I wanted him on the paper, that was also part of it. I did recognize my advisor's name might carry some name recognition. For reviews, depending on where you're submitting it, they may not matter if they do blind reviewing. But even after the review process, their name being on it might increase the number of people who will take it as a credible paper, right? I know a number of you, when you did your quick browse, right? You quickly, some of you had like, look, I recognize that author's name. I'm scanning this one, right? That was it. That was the entire decision, right? I didn't need to browse, right? No, I know who that is. They're a big name in the field. I'm reading it, right? So having a big name in the field after yours, right? That can help in terms of actual readership. So that's another reason to consider. But my recommendation is get the value out of that name, not just the name. Get them to help you make the paper better.
From the publication standpoint, right? We have a paper that is like published like not like great writing. Would you when you say like the automatic export papers, you said right?
Say that again. So you have a paper published in a not very good venue.
Yeah. So should we have it like in our survey paper like as a listing or that's good for our publication?
So it depends on how you refer to and what you refer to, right? So the fact that the paper showed up in a bad venue doesn't necessarily make it a bad paper, and the fact that it showed up in a good venue doesn't make it a good paper, right? So first and foremost is, does the paper actually have good content worth citing and talking about? And then how are you talking about it, right? So if you were to actually take a paper and say, this paper that shows up in this bad venue, right, it has this proof, which we're going to accept as true and move on, right? Then you're running a risk, right? If the proof is not true and people don't believe it. On the other hand, if you say, this paper in this bad venue made these wild claims that we can prove is wrong, right? Then it doesn't matter that it's in a bad venue. You're proving that this statement that some people are making is wrong, right? And of course, it's hopefully more likely that you can prove the things in the paper are wrong in a bad venue than in a good venue. It's more exciting and surprising, good for success, if you can prove something in a big venue is wrong. But that's a different side. So archive is actually probably the most interesting example of this, right? Archive has become, in some fields, like the de facto place where people are publishing things. And some venues have rules about when you can and cannot cite archive, when you do or do not consider it to be even published. Because archive, if you want 20 papers, you can upload each of your notes from this class. They're in LaTeX, right? That's the one requirement to go up in archive, right? Is they have to be in a format it will digest. It digests LaTeX, right? Okay, you can upload your journals and give them titles and make them look like papers in archive. No one would ever cite them. They have no real value, right? So that's the limit, right? Archive can have almost anything. If it's not plagiarized, if it's not copyright infringement, archive is not going to make you take it down. They actually have been started to do a little bit of people using it as a way of a repository for like business manuals for their companies, right? But so they may or may not. They don't actually have an official rule against it yet. So I could take all of my users' manuals and upload them to archive for my company, and now have them in a permanent place that's maintained, and I can just cite them as archive papers, and make my company's technical stuff look good. It's like, as seen in this site archive paper, right? It's just a user manual. What does that mean? But they have to forget those. But archive it's up to you. There's actually lots of highly cited papers in archive, and there's lots of absolute garbage in archive, and you got to figure out which ones you want to cite and which ones you don't. So if you want to make your paper really up to date, there's actually right now, because of archive, I would say at least 80% of the stuff in archive, maybe more, has the goal of actually being published someplace else. So if you're citing a paper that came out in 2018 that's in archive, by the time your paper gets published, their paper may be published, and then it looks like you're citing really recent stuff, because it's based on the same content. So there can be a reason to want to, because it's got good content. So the answer is, it depends. And it's up to you to make the argument. Anyone else, you want to tell us your papers?
Do they
I'll show you the scope. Okay, so in the black box, white box, I would recommend you think of it as more than just blacks and white. There are papers that have gray box attacks, and for black box, how much do I get to know? Right. So there's black box attacks where you get to run the system as many times as I want, but I only get the score. Right. And then there's other things which we've been in my lab, I've been trying to convince my students to call zero-shot black box attacks, where I have to attack the system and I am never allowed to get its output. I have to attack it knowing that I can't run it, right? So I have to design an attack based on whatever else I get to know. I can build, duplicate networks and try and train and figure out this is what it's probably going to do, but I never get to hill climb on the network of space itself. So that makes that dimension just a little bit more interesting than just the very classic black and white, because now there's shades of gray along it.
Under the profiling tool,
Mm-hmm.
and there are a lot of papers that implement knowledge tools, and there are also papers that use the profiling tools to profile machines and something like that. And then the layer of the hierarchy that I didn't really see was energy, apparently energy consumption is a big goal of profiling tools. But inside of that, there are also optimizations that you have to define and keep your results. But as opposed to energy consumption, there's also just a form of optimization. So your profiling program, some code with the goal of optimization.
Well, so actually, energy optimization is one of the potential optimization goals for optimization. I can have speed, size, energy.
So can I switch that into like the paper is energy focused versus optimization focused, or do I have to say that energy optimization requires like lower levels of optimization?
Right, so you could be looking at it. Well, so the answer is how can you? You can do it lots of ways. So, but you could have, for example, speed, size, and energy as in columns this way. Right? Try a different one. And then over here, I could have, in terms of my tools, right? I could have optimization, some sort of novel restructuring. I don't know. I'm just making some up. So, but down this dimension, and then I could put, some papers are here. Some papers are over here. And maybe even the same paper shows up twice, right? In these different categories, right? Where you're looking at what is their goal of their performance enhancements, right? What is the techniques they use? And in here you can have some range of different techniques. Okay, so novel is really like it says this is new, but that doesn't actually tell me anything about the category other than at the time it was done, right? So a paper published in 1957 might have been called novel performance optimization, right? Not novel anymore, right? So you got to figure out a way to sort of divide that into finer pieces. Anyone else?
Quick question.
Yeah.
I've seen a lot of IEEE students use soft papers, systemization knowledge. Is that an IEEE specific term, or is that industry-wide?
I'm not sure if it's industry-wide, but it is definitely, you'll see it in more than just IEEE papers, that's for sure. So, it is, so unfortunately, it gets the same acronym gets used in other places to mean other things, like system on a chip, and some, but so within the software space for attacks, but I mean those terms show up in like DEF CON talks and whatever, so it's not. Yeah, so be a little careful. So if you do have a bunch of acronyms, it is strongly suggested that you have a definition table. Like here's the acronym, here's what it means in this paper. Especially when you just take your generic TLA, right, and you have to expand that to whatever three-letter acronym it means in your space, because it's going to be reused. Anyone else want to share things they're struggling with, things they're happy with?
Quick question. So, do you want us to do it more for the general audience, or do you want to do it more specific?
I want you to gear it towards the audience you want to gear it to. Right? I'm not going to tell. I'm just telling you that's another way. If there's already an existing one, right, you can have a new one by taking some of the same core and aiming at a different audience, which really results in a quite different paper. Right now, if you went from it's for blockchain super geeks to average cryptographers, It may or may not change it enough, but it might actually, because right, the blockchain people might just presume all of this stuff, and the cryptographers are looking for all these proofs, right? So if I went that dimension, I might be like, which of these papers actually have proven techniques, and which are ad hoc and still not implemented, and which are field tested in the whatever. So it can come up with lots of ways of categorizing it, but I don't care.
So, a little off topic, but so in my research, I kept I wanted to look at different angles of information systems line, like so people don't look at blockchain, look at it very technical,
Mhm.
what are information systems? It got me to a journal that looked like it had several papers that were relevant, but simply couldn't access it. If I can learn enough about a paper from its abstract, is it still okay to use that as a reference, or do I need to be able to actually read the entire paper?
So that's a good question. I will tell you, I often cite papers based on their abstract, depending on what I'm saying they do, right? If I only take information that is in their abstract, then it's perfectly fine, because anyone who reads the abstract can verify that information. So if we say this paper looked at this application of blockchain to cannabis, right? And that sentence is in their abstract, it's in their abstract. That paper definitely looked at it, right? If I say their technique, their paper does not address the problem of this, I can't decide that from the abstract, because the paper might have addressed it and it just wasn't important enough to make the abstract. So you have to be careful what you say about it and how you put that together. But if you can state something from what you read in the abstract, then it's perfectly fine to cite just the abstract. It is good to try and get the real paper. So you might ask our reference librarians. If you've never been, our library has a physical presence. Actually, I guess it's over there, right? The reference librarians, one of the things that may not be obvious is you may not be able to get it in Google Scholar. First of all, you can actually go through the library's interface and get to the library databases. But the library is actually pretty good for PhD students in that they will often get stuff through what's called interlibrary loan, right? So they can get you a physically scanned copy of a paper that exists only in paper form. Right? It's not going to be today, not gonna, next, it might be next week, it might be the week after. But if there's something you want that our library doesn't have, we are part of a library consortium, and they might be able to get it from one in Boulder, or they might be able to get it from Columbia University in New York City, right, through interlibrary loans and get you things, right? So if you feel this material is actually really relevant for your research, go ask them. Don't just say I couldn't get to it, right? You might even say, okay, I'm going to cite the abstract, and now I'm going to get the full paper, so that by the time this is done, I'm really sure what's going on. That gives you the expediency of a quick citation, but follow-up to get the real material. Okay, any other questions? If not, I'm going to move on to talking about Katrina. Okay. Okay, so if you tell us about it, yes. If I can't see through your computer, so. Okay. Right, right. So that's design versus retrofit. Okay, yeah. Statistics. Okay.
Like breaking down the slides, and then maybe below that, just throwing out some images.
Okay, so the way you described it, you kept describing it as a tree, but the tree methodology really only works well if once I go one dimension of the tree, I don't see the other features again, right? I would actually say yours is closer to this sort of right cross product of, because I can talk about the level of ML and the level of retrofit versus design and the level of integration. All of those are dimensions that interplay together, not like so security and privacy, right? That's a pretty right. Security goes over here, privacy goes over here, and that's what these papers are predominant. The same paper might show up in multiple cases, but there's really not like the full cross product. But everything you described could easily be broken into multiple categories of like the level of retrofit, the level of integration, the level of ML being used, and that gives you a bunch of cells, and then you get this greater opportunity to identify gaps, right? So if you just start enumerating things, it's really hard for the reader or for you to identify a gap in something that is really just here's 1, 2, 3, 4, 5. Now, admittedly, if it goes 1, 2, 3, 4, 5, 7, you can enumerate a gap. But if you're numbering them, why will there be a gap, right? If you start doing it this way, you might see a few more things. Does that make sense? And another thing, coming back to those who are finding lots of papers, there's another kind of paper, well, two other things related. So one is actually a survey of surveys, right? So if you actually get into a space where there's so many survey papers, there's actually the potential to do a survey where it's like, and like this box here, go to Bob's survey, right? There's just so many papers here. This is like where everyone is. I'm not even going to survey this, right? It's already been well covered in this, and you give like a short 1 or 2 paragraph summary of it, but Bob's got this well covered. And then in this space, here we have Nancy's survey, right? And then these other boxes are the ones I'm going to spend more time on, right? So you don't have to cover all of the same stuff other people have covered. You can actually go cite off a survey. So in your space, right, there might be subsections of your space where there's a ton of papers. There's actually a survey paper on interoperability in IoT, right? There actually is one, right? So you don't have to cover all of that. You can actually cite that off, right? But some of the other papers you've surveyed also touch on that, so you can put them in the right place without trying to make sure you cover everything. Now the person who's really interested in that has a place to go read more.
So then, I guess if my organizational categories that I was trying to make a tree are that right side of your diagram, what's on the top?
Okay, so in your case, right, these numbers don't matter, they're all. So I might have level of integration, or level of integration. So here I might have design, or actually, I guess here I have retrofit. Right? And then, so retrofit to design, right? There's no smart city that was designed from scratch and built, right? The city didn't exist. It was in the middle of nowhere. Washington, D.C. was not a smart city design, right? Washington, D.C. is not even a smart city, right? But no, so the city was later. So maybe there are some new ones, right? So they're complete designs. And then there's ones where they design like this integrated, large level, and then there's like piecemeal retrofit where everyone's doing their little pieces together. So you can get a couple of categories. So I can view this one almost as a dimension that's continuous, or I can break it up into 3 categories, right? Piecemeal, integrated design, retrofit, full design, whatever, right? So you're just making some variations there. This dimension might be the level of ML, right? Where here it's none, where it's a lot, right? And now you can categorize them, right? Because that's, again, almost a continuum, right? They use no machine learning. They used a few applications use machine learning, but most were custom control loops to everything is learned. That's what you want to do. Again, I'm not saying you have to do this. I'm just giving you feedback. This helps people understand it in a broader spectrum than just here's this list. Okay. And again, hopefully this will help then identify a gap, right? Maybe all of the design cities are all using ML, but no one's done much ML in the medium retrofit or whatever, right? I don't know where they are. Okay. We have time for maybe one more.
One off-topic question. Do I have to cite the author if I would rather protect their identity? Like in my virtual security example, I don't really want everyone to know this idiot said change the default settings. Can I just put that in my paper with generic quotes around it?
It's So you can. So the question is, how credible is it if you don't actually cite it? And that makes so somebody might want to go read that paper to verify that. Right? So it's tricky if you're looking at it from this person might be a reviewer point of view, right? But I would actually still go ahead and cite them. Just make it about the paper, not about the author. Don't say Bob said this, right? Say there have been papers that, so you can do this. This is one of the times when you use third person and passive voice, right? It's not like, there have been papers that made very straightforward, simplistic suggestions like moving away from the default. That's a good idea, but it lacks the specificity of what changes we should make, right? So then it's not so bad, right? As opposed to saying, some idiot said this is all we have to do, right? So don't be pejorative, and it should be fine. And oddly enough, there are definitely papers that get more citations for being stupid, right, than you might imagine, right? We're aware of some papers that we've dealt with where the paper has like 150 citations, and you're like, why does this paper have that many citations? It's because it's so stupid. People make fun of it all the time. It's fun to make fun of it. It's a well-known paper, right? So don't worry too much. The paper might have its other people wanting to jump on the bandwagon and make some claims about it. So you may actually help the authors. They may become infamous, but it's still better than being unknown. So actually, we'll go ahead and take a 5-minute break because we haven't. But then I'll get into the next bit of material. And so if we didn't get to talk about yours in class and you don't want to talk about it publicly, I'm going away on a trip this week, right? But if you send me mail, I will still try and answer. Like if you think yours is okay, I'd want to have the journal. So if you notice, I moved the journal to be due like tomorrow because I forgot to assign it. But there should be a journal due every week. I just forgot to put that up, so I put a couple up. But I also want the journal to be about your journey as you're doing the survey paper. And then I realized I want to give you feedback before you turn it in, right? Because it just, right? Hopefully, is this helping people, this kind of discussion? Right, so that's why I want to have a discussion. So if you didn't get it because you're too embarrassed to talk in class or you just don't know what's going on, send me mail. We can still do this by email.
So what is the piece of
So I'm gonna move the survey paper and the journal to be due Wednesday. So, no, Wednesday this week, but so you get an extra day or so in it. But actually, yes, just because it makes it easier for the grading, right? I will recognize it the second time and give the same grade, but otherwise I might forget. So actually, I'm going to move it to Thursday because my talk is Thursday. So I will spend all day Thursday meeting with people. I will get 0 done Thursday. So I'll make it due midday Thursday so that I can make sure I get it downloaded before I fly back on Friday. Okay. That'll probably, by the way, move the final paper back a week as well. So each of you should upload it. Well, no, so each of you should separately upload it, right? But it can be the same document, yes. Yes, Uma.
So, I'm confused of what I'm doing,
Okay.
but I just wanted to talk to you about it. So, right now I'm working on Daniel's instrument with different cultural students in India to work on it and do some data analysis and write the paper on it.
Yeah.
But
That's a research paper.
yes, so now for my dissertation, like final dissertation, I wanted to branch out and do some facial expression image analysis. And so my question here is, do I write a survey paper on what I'm working now or what I wanted to work? Because
You can write a survey paper on neither. I don't care, right? You can write the survey paper on whatever is a good survey paper that you want to work on.
okay,
Right?
so
That's
right.
between you and your advisor, right? So
Oh, she gave me like
freedom to do whatever.
to
Okay, then it's whatever.
But I was wondering if I could. There are so many techniques to do facial expression analysis. So I was wondering if I can compare different types of techniques and write a survey paper.
So compare in what sense?
Like, what their approach is, and
So that's to be expected in most survey papers. You're looking at how they do stuff, right? How it could be applied. That's right. So there are surveys and facial expression analysis, right? So you got to also make sure yours is
Right.
different enough from theirs, right? But if you're looking at facial expression analysis for indications of confusion, right? Because that's really right. You could do the survey and is what techniques may or may not apply to confusion and why,
okay.
right?
That's my question. So there are like a lot of survey papers, like including every expression, but they're very limited, I guess, for the confusion part.
Right.
So,
But there are some.
okay.
There's at least some work. I don't know if they're survey papers, but there's at least some work where people have tried to figure out. And I can also tell you if you we can talk about this later. So, but in the space of confusion, confusion is often really only understandable from video, not from a still image.
Yeah,
and
those are the papers I was reading, like analysis from a still image and videos.
So and if you haven't, so you can analyze all those techniques and then suggest these are the ones that may or may not be useful for understanding confusion.
Okay, sounds good. That's
I just want to make sure I was on the right track because I said that it was a little weak and maybe I misarticulated. So here's the idea that I wanted to go for, and I had this before. So we have a piece of software, and this is going to categorize how a researcher goes around looking at it. They have the source, and then they have the binary, and they have both.
Okay.
So then they're going to break them up even more and saying, well, we'll use static or dynamic, and go through that later. And I can even, this is just an initial draft. There might even be more that I'm not even looking at. But the point is that try figuring out where the community as a research community is focusing their time. But I think a lot of the time is being focused right now.
So again, when you look at one where you have the same leaf labels everywhere, that suggests you want it to be one of these. Because what you really have is people have static and dynamic, and then they have binary and source, or both, right? So now you have this matrix, right? And then you might fill in things in slightly differently than viewing it as I've made a split, right?
Okay.
Because binary versus source is a split. Static versus dynamic is a split. But you're trying to do both splits, right? So it's not quite, I mean, yes, you could organize it as a tree, but if I'm really interested in all the dynamic techniques, right, I want a column here that says dynamic, and then I can look at all the papers that are telling me these are all the dynamic techniques.
So a matrix might be better to
Right.
organize that.
Yes.
Okay, cool. But I'm definitely on the right track.
Yeah, that's fine. Answer for those subcategories.
Okay, because I have a feeling that there's going to be like a gap that says, hey, we have to look in this area.
This area, that's
But everyone's focusing on this area.
right. Yep.
All right. Two questions. This survey will be part of my oral exam,
Okay.
so I want to speak about that one. But now, after discussion with this class, would it be possible to survey how the CIA is implemented and applied on the field that I'm working on, the NDM? And then I'll go starting with like confidentiality and break it down like when it goes to the access control, when it goes to the trust management, when it goes, and then I just list everything implemented as well as the confidentiality, and then jumps to the integrity and then for the availability.
Right. So yours. So for those two, because those three really are a true category, right? So to have CAI, which is not how everyone does it, but I don't. To me, this I don't want to confuse, right? So you can break them up into how they do this, right? And then in here you can have some categories, right? So just what I was telling Dustin, Jason, if you end up with the same thing here, so let's say we have some module here, the same module. If it keeps showing up in almost all of these, then it's better to view it as a matrix. If it really is after each of these, because for these they really are generally pretty different. What I see here is generally not repeated over here.
Okay.
Right.
If it's repeated, then should I take it out or just?
No, you can. So if it's repeated once or twice, you can just talk about it being repeated, right? But if it's repeated almost everywhere, then it's better to make a new dimension. And
Only for that part or for?
only for that part, right? So well, if at the top level, right? So you have CAI, and then you have something else where, and again, I don't know how your space is, but if I think about you're doing name data network, right? So if you talk about like how it affects the routing, how it affects the naming, how it affects the control, right? All three of those things might show up in each one of these categories, right? And then it really should be naming, control, routing, right? And then you get a matrix where you see how things show up, and this paper's addressing the confidentiality within the naming space, right?
Okay, so there's another question. That's good. That's very good, really. But I'm always trying to focus more on security-wise than the architecture itself. But yeah, this is fine.
Well,
So-
this side is the security, right? And this is saying how that security is impacting different parts of the architecture.
Oh, that's great. So now, as you know, this NDN is not one known for everyone. So in my survey right now, should I include like more than one section maybe, or one page explaining what the NDN is and explain its contents, factors, and contents?
That's fine. Yeah. So
Actually,
if your surveys, so it depends, right? So it's not extremely well known. So if you have to explain named data networks to
As long
right,
as for the
map,
ACCA is not well known, I'm pretty sure. There's
well,
no-
but so even in the field, right?
No,
Within the
the field is-
people who are normally doing security, it's not well known, right? So
Right.
you're writing that for your audience. That's fine. It could be a page or two describing here's
Okay,
what this
good.
is, right?
So this is not a
And
problem,
so
right?
one way of looking at it is if you had named data networking elements here, right? You're going to explain these dimensions well enough. And if you make the architecture part of that dimension, then you have to describe them all and how it works. Otherwise, no one's going to understand your division, right? These are so well known, but you still have to have a paragraph on each of CA and I, right? You have to have at least this much.
This is the next question now. Should I first start with explaining what each part is and then jump to the security section and then I go demonstrating how that implemented in each?
Okay, so I would actually still start with the high level. Here's I'm breaking it up, right? So that those who know named data networking can jump right to the right area,
Okay.
right? And then you can say, for those who don't know, we're going to describe all of this. For those who don't know this, we're going to describe that, and then we'll get into the papers.
Okay, which is how this implemented in
Yeah.
this, right? That's good. Thank you so much.
Okay.
I'm going to do it before I forgot.
Do you have time for me or?
I said 5 minutes, but okay, is it quick?
I just wanted to know about my organization. I will talk about the open source transformation, and I will divide it to two, in fixed and in vision.
Okay.
So what do you think about that? Because in vision, like there's a lot of paper, but in fixed now, in vision is difficult. Yeah, in vision is too difficult because I'm beginner to the whole machine learning tool. But in text, it's more like easier for me.
So there's papers, but inside of, especially in vision, you might want to break them up. So there's other ways you could break up OpenSet further. Obviously, right? If you look at my paper, you could look at how formal are they about OpenSet. Okay? You can look at, are they doing OpenSet using features or using the raw data? Because those are actually two very different problems, right? And in vision, almost all the papers are in OpenSet using features, not in the original image space. Adversarial images break all that. Same is true for text, right? If you do it in feature space, then adversarial images don't make sense, or adversarial text doesn't make sense because you're already in the feature space. But they're broken in the input space because I can make their own features. So there's a wide range of subgroups you can make besides vision. That's a high-level split. Right? After that, are you going to split them further? Right? Because in vision there are different levels of splitting. In text, there might not be. They might all just be here. But if you were to also look at them in terms of the techniques, so extending SVMs, using some radial, using a density function. Right? So there's categories of OpenSet algorithms. So I published lots of them, but there are algorithms that are OpenSet that we didn't ever publish. We just mentioned them as, yes, these are also examples of OpenSet. So if I do any Gaussian GMM and I threshold it, that is OpenSet, because they're Gaussians and a threshold, so that you can generalize. You can talk about papers that are OpenSet despite not even calling themselves OpenSet. Right? That could be a part of your survey. Right? There actually are many papers in text processing that are OpenSet.
You said there is a lot of paper considered as the OpenSet, but they are not OpenSet?
No, the other way around. Papers that don't say they're OpenSet, but they are. So if I take an HMM, and hidden Markov model with Gaussian states and probabilities, and I threshold the probabilities, you can actually show that that is provably OpenSet. Because the Gaussians in my HMM basically define parts of feature space. So there's Gaussians for my transition probabilities, and if I threshold them, and then I look at my space, because the Gaussian satisfies in one of our papers we talk about what's called a cap model. So anything that is decreasing probabilities that get thresholded is OpenSet. right? So your survey paper could actually be identifying a whole bunch of papers in text processing that are open set but didn't know it or didn't call themselves that.
Okay. I didn't get that point in my paper, in my survey professor job. Do you think with this is it okay, or I should add more now, or keep it just for the?
This is like only 2 levels, right? And that helps the reader a little bit. Here's text, here's vision, but there's not much more than that. So this is just one. I'm just throwing out. There's lots of other ways you can continue to refine them, right?
Okay.
Beyond that. So see if you can think of one more layer of refinement for your text or your vision side.
Refinement?
So your hierarchy. So right now you have a top level, and you say vision, text.
Mm-hmm.
Can you do something where you break these into a few more categories?
In text, I don't think so. Because I didn't find like a lot of resources.
Right. Well, that's what I'm saying. So you said that. That's why. So here you have the ones that are saying provable, open set. Right. These are the ones that claim to be open set. But maybe there's these other papers you can put together which are also open, but not claimed. Right. So now you can have 2 categories. Those papers that are open set algorithms, where you can say, because this paper over here defines cat models, right? So this is something we defined. Given that this is a cat model, you could analyze a bunch of other papers in natural language, and I'll bet you can find some papers that are over here, right? Even if right now all you say is, look, these are the ones that proved it. This paper over here says there's this idea of a cat model. So there should be papers in natural language that are. And if you find a couple examples, then you fill in another category over here and make it a little bit more interesting. But for tomorrow, for this week, you can just sort of describe these categories. You don't have to find these papers. So either these papers don't exist, which is a gap, which is interesting, or the papers do exist and no one's looked at them that way, which is interesting. So either way, it's interesting.
Okay.
Okay?
Yeah. Thank you.
Okay, so we're going to get started. I'm a little behind my timeline for today. I thought we'd be done this before 6. But so we're going to talk today about the actual writing of papers, and then we're going to talk about figures. And hopefully we'll get through both of these today. We got an hour and 5 minutes. I'll talk fast. I always talk fast. Okay, so writing paper is a skill. We talked a little bit about this last week. It's a skill you can learn, and that's part of what we want you in terms of research methods in computer science. The most important research skill I can give you is helping you write good papers, right? Because the rest of it won't matter if you can't get somebody to help you write a good paper. And it's definitely worth learning. The more your papers will be accepted, the more brownie points you'll get, you'll have better ideas. That's actually, to me, the best reason. Hopefully this exercise, in fact, the first exercise in browsing and now this exercise, right? If you find a better way to break up your space, it provides clarity of thought and help identify, here's research opportunities I can work on. As I explain my research to other people, I can put it in a better way. So that will actually help you. So here's what many people think of as the model for how to do a paper. You have an idea, you do some research, you write a paper. Nah, that's not how we do it. Okay? My recommendation is you have an idea, you write the paper, you do the research. Okay? This is actually closer to the scientific method. You have a hypothesis, whoops. You have a hypothesis, and then you go out and test it. And the only difference is when do you write the paper. Okay? My recommendation is as you write the paper and you go out and do the experiments. Now, there'll be some overlap. It's not completely sequential, but you want to be writing the paper and understanding this is what the paper is before you do any experiments. Why? Because if you think about our tetrahedron of science, truth, storytelling, or whatever, there are many stories I can choose to tell related to the same absolute truth. And I can write experiments that prove the same absolute truth but tell different stories depending on where I want to go with it. So that's part of what you want to do is you want to figure out, here is the story I want to tell, and here's the experiments that show that story. Okay? And part of the answer is it depends on where I'm submitting the paper. In my field, if I'm submitting a paper to NIPS, I might do one kind of experiments, and I would have proofs in the paper. And if I was submitting it to CVPR, I might have a very different data set with the same algorithm, and no proofs, and spend more time on large-scale experiments because I'm writing the paper from here's how it helps in real-life problems. And if I was going to the winter applications of computer vision conferences way out in the application space, right, I would focus way more on the applications, and I want to make sure my data was more realistic. However, it might be the same core idea, but 3 different venues call for 3 different sets of experiments, right? And so you start writing the paper, you choose the venue, you figure where you're going, and then you start the experiments. Often as you write the paper, it really helps you crystallize what you don't understand and what you need the experiments to help you prove to make things go along the process. And often it just helps refine the idea. As you're writing the paper, you start talking about what's the experiment, what's it going to show, what's it going to measure, because that's what you want in your story. And as you do that, it helps you refine what the experiments are. Okay. Now, realistically, that I think is also a little bit naive. Here's the real model, the right model. You do the idea, you do a draft paper, and at this level, you're not worrying about grammar, English, you're just putting together, here's the storyline, here's the core elements of the paper. Here's the related research, and I forgot to mention that when I did the last one. Before you do experiments, you really got to know all the related research because you might have to compare against them. And when you read them, you might recognize, oh, my idea is already done, right? There's no point in doing the experiments if your idea is already done. You got to figure out how to make the idea different enough that you can do this. So that first part of reading the related research paper, doing the related work section is actually really important. Then you do the research and the experiments, right? Then you revise the paper, and very often you iterate. Because what you thought was going to be the story isn't supported by the experiments, or it is supported by the experiments, but you have a better story now that you've seen the experiments. It gives you some ideas to go someplace else, and so you iterate a couple times. And the advantage of this model is it actually allows you to find the best story in what you have. You had a good story, you did the experiments, and then you might find a better one. You can do that. So, and this really separates this idea of shitty first drafts, which we talked about last week, from the final paper. And it makes it easier to say, I don't care how good this is, right? Many of you will get stuck with writer's block because you don't know how to write it up. Well, the first draft isn't about the actual final paper. It's more like, here's the story of the paper, here's the elements I need to have so I can go do the research. But then your advisor can be looking at that, giving you feedback and having a conversation and not worrying about what's the quality of the writing. If your advisor is one of those people who can't read it until it's ready, well, then this draft is just for you. That's okay. Okay. So it's really important when you go down this path not to be intimidated. Many people incorrectly believe you need to have a fantastic idea before you can write a paper. And many of you will think, well, all these papers I read did. Now, first of all, you've browsed through enough papers. I guarantee every one of you has seen bad papers that have no idea, okay? And yet they were published. So there's hope, okay? But realistically, right, you may be surprised the ideas you think are not good are actually good. As you write a paper, give a talk about any idea, whatever it is, right, no matter how weedy and this you may seem to find it, you're going to get better at telling the story of ideas. And you might actually find the idea has more of a core story than you thought. It might have started as a simple observation, but as you dig into it, the observation might develop into a theory that's actually provable. Or it might be the observation leads to other observations that does so. So don't worry. You really want it to get going, right? As you write the paper, give the talk, no matter how bad it is, you will improve. Even if the only thing you improve is your ability to tell the story, that idea really was crap, it's okay, it's dead, you move on to the next one, right? You will have lots of ideas, okay? Don't worry till you have the best idea you're ever gonna have. But writing is actually a great way to actually develop the idea. As you try and formalize it, I'm sure you've all had this feeling, and I have it very frequently because of my dyslexia and the weird way I view the world. Like, there are times when I can't even think of the words to describe what I'm thinking, right? It's just in my head, and I know it's there. It's this vague thing. It's like this, and it's like I don't know what words to describe it. And that's a very common occurrence to me, but it's true for most people. You have this idea, it's in there, you know it's there, you just can't get it out yet. As you write, you will get the idea out and you'll make it better. And very often, it turns out to be more interesting and challenging as an idea than it would first seem. Sometimes they really are trivial. The biggest problem is not that the idea is not interesting, it's that it's already been done. Okay, so you might have been extremely creative in what we call the personal creative space. To you, this was a completely new idea. Unfortunately, to the world, it's been well known for a while, but that doesn't matter, right? If you develop the insights that let you effectively do something that a great person did 20 years ago, or even last year, right? That's actually showing you're being creative. Now, if you read their paper and you forgot about it, and then one day you recreate it, it's like, that was in there. But most of the time, that's showing your creativity. You're just not yet at the forefront, so you got to get in front of everybody, and then you'll still be doing it. So you got to figure out what's the purpose of your paper, okay? Now, many of you have some reasons to try and publish, okay? It's not really to impress others, to gain recognition, to get promoted. That's okay, but that's not really why you want to write a paper, right? You're really writing a paper for what reason? To graduate. Well, so that is unfortunately a truism. You need one to graduate, so you're going to have to get there. But why are we doing that? Why do we make you write papers? What is the real goal of writing a paper? To be a teacher? No. To communicate your ideas, right? You're really going down this path. You're getting a PhD. A PhD is a degree about research. And really, good papers and good talks are a fundamental part of research excellence. It's about us teaching you this is how you do research. We want you to really understand that, and that's part of it. And it really is about communicating ideas. Your goal when you write a paper is to infect the mind of your reader, ideally like a virus, okay? Because it's like a virus, because what you want is the ideas now in their head, and they're going to talk about this idea with 2 other people, and now they're infected with your idea virus, and then they're going to talk about it with 2 people, and pretty soon everyone's blonde. I mean, that's a commercial, but no, it'll just keep growing until your idea's out there, right? That's why we want it to be like a virus. You want it to spread, right? If you have to force feed every person to get the idea down their throat, you're not going to get your idea very far. But if your idea is so good that anyone who sees it wants to give it to someone else, then your idea will grow, right? And literally, we're trying to design them so that other people will share them without your input, right? You want people who cite your paper because they saw somebody else's discussion of it that was so exciting, they had to go read it themselves, and that's where it's going to go, okay? The ideas are far more durable than your program if you can actually get a good job, do a good job with your papers. And ideas are one of the few things which are not diluted by their use. If you have an idea and I have an idea and we each share them, we now each have 2 ideas, right? It's not like when I give up my idea, I lose something, right? Everybody I give my idea to, the more people I give my idea to, the more value my idea has. So they're literally worthless if you keep them to yourselves. You've got to get them out there. And unfortunately for you, you don't get to give the same idea out too many times before people start saying, oh, that's the same idea you had over there. What can you give you credit for it? So you want to put that out there and give it a chance to really grow. Okay, so the idea. An idea is a reusable insight useful for the reader. Now notice, I didn't actually talk about this from a research point of view. This is true of a survey paper. This is why I'm trying to push you to categorize stuff, right? A reusable insight that's useful to the reader of categorization is something they can look at and they can break down the world. If your idea affects the way they view their field for the next 8 to 10 years, you have had a profound impact on that student, on the way they view the world, on the way the world develops. And whether or not they cite you all the time, you are having that effect. Your idea is spreading. Okay, so you got to figure out what your idea is, because it's almost assured that if you don't know what your idea is, you're probably not going to communicate it very well. So you got to figure out what it is. And once you figured out what it is, make sure the reader is in no doubt about what the idea is. Right? You've probably all read papers and you're not sure what the idea is. But if you read a paper that says, the main idea of this paper is, and then a sentence, you know what they think it is. The main contributions of this paper are, right? And a bulleted list of items, right? That should be in the introduction of your paper. Now, you might not be that explicit, right? So you could start with, in this section, we present the main contributions of this paper, right? Right. The main novelty of this survey is our categorization, which allows us to place these recent papers in the context of whatever, right? Many papers actually have good ideas, and they don't distill them. I went through a culture at Columbia where we had some scientists who felt we shouldn't tell the reader what to conclude. It took me a long time to unlearn that lesson. You should tell the reader what to conclude. They may conclude some other stuff, and you should support what you want the reader to conclude. But it's actually a good idea to tell the reader what you think they should conclude. They can disagree with you, but it shouldn't be up to them to draw the right inference from your paper. That's just too much effort for the reader's part. Okay. I like to think your paper should have one ping, one simple idea. You can have a few embellishments, but there should be one really clear, crisp idea. When they're done this paper, they know here is the core idea. Okay? If you have 3 ideas, you may be tempted to want to pack them into one paper and say, oh, look at the value you're getting. There's 3 ideas in this paper. And if you're allowed to write a 60-page paper, that's okay. But if you're writing a 10-page paper, 1 idea per paper. If you got 3 ideas, 3 papers, please. Right? Because you just muddle them together. It is too hard to get too many different ideas in one paper. And I suffer this malady myself. I regularly get my papers rejected, and we had too many things in them. We took our first paper on OpenSet after it was rejected multiple times, and it became 3 papers, 3 15-page papers before we got them accepted. And we had to get them accepted one after the other, because it was just too complicated to put together in one paper and get everyone to understand it and feel comfortable with it and have experiments that showed it and whatever, right? Break your ideas. So if you have multiple ideas and you can delineate them, now you want to be a little careful about the LPU, the least publishable unit. Your goal is not to figure out how can I divide this idea into 17 little pieces and publish it 17 times, right? It might be 3 or 4, probably not 17. So many of my students have these things in their thesis called chapters. And I sort of expect this paper is chapter, so there's the intro, the related work section, which might be the survey paper, and then there's chapter 3, that's a paper, chapter 4, that's a paper, chapter 5, that's a paper, chapter 6, that's a paper, and then we call it a thesis, right? So especially if it's the same theme, right? If you think I can pack all 3 of these into one paper, then you can pack all 3 of them into one thesis, right? If you can't do that, then they didn't belong in a paper together. And there are theses that are really hard to connect. My personal PhD thesis, no committee member, they discussed it among themselves. No committee member read more than 2/3 of it. Because there was a part that was very, very extremely high dimensional mathematics, a part that was computer vision, and a part that was psychology experiment. The vision guy read the psychology experiments, the math guys read the math and the vision because it had some math, but no one read it all, right? So that's not an ideal thesis. You really want a thesis that tells a coherent story. One of my students, Ethan Rudd, who graduated a year and a half ago, right? He had 15 to 17 papers, right? Only 5 of them were in his thesis. The rest were just simply things he had done that didn't show up in his thesis, right? You make a coherent story out of stuff. You don't have to have it all in there. Okay. So if you have lots of ideas, write lots of papers. Okay, so the purpose of your paper is really never to describe the whiz-what, whiz-bang system, right? That's not your goal, right? Your goal is to really simply get them to have some reusable ideas, not here is the state of something I did, right? This is not art history where you say, here's a description of a painting and here's how I interpret it, right? This is knowledge you want to give them, so you want to put it together. Okay, so what does your paper look like? So you're going to start your paper with this idea. We'll get to the formal structure in a second, but you want to have the intro, which is really describing, here's a problem. See, it's an interesting and important problem. It's a really big problem. Here's the more unsolved version of this problem in our space. We're doing the funnel coming in. Here's my idea. That's the core of the paper. Here's how my idea works, details, data, and then it's going to compare to other people's, and then we're going to come out to a conclusion, right? So this is still in line with what we talked about last week in terms of the story and stuff, but now we have to put it into pragmatic terms. What are the sections you write in a paper? So a pretty standard conference paper would have title, an abstract, an introduction, the problem, my idea or my approach or the method, something like that, details, the experiment or something like that, related work, conclusion, and future work. Does Does anyone see anything different in this layout than what you're used to? You've now gone through lots of papers. Bless you. Yeah, there's no acknowledgement, but I'm actually talking about the order of these sections. This is intentionally different from what you're used to seeing. Yeah. So we'll come back to why this is, and I don't always do this because you have to balance getting this in with what your community's used to. I've actually had papers where I put them in this order and people complained about the related work being at the end. They are so used to it being in this place, that's where they look for it, they get annoyed. One of the reviewers actually said there was no related work because it wasn't in the section after introduction, right? And they clearly didn't read to the section that was called related work, which was just before the conclusion. So you got to balance if you can get away with this or not. But I'll talk about why this is actually a better direction. So the abstract. I actually generally write the abstract first and last, but I wouldn't call what I write the first time the abstract. I write the abstract last. After the paper's done, I go back and write the abstract. When I first write it, I look at that to sort of say, here's what I think the paper's going to be about and the story it's going to tell. And then I ignore it pretty heavily. And then I come back and finally write it. And there's definitely been papers where I don't even write the abstract. I just start with the intro because the abstract's the shortened version, so why take the time to make it sort of short? If I have a pretty good idea what the story is, I just write the introduction, write the paper, do the experiments, rewrite the paper, and then write the abstract. And this guarantees that the abstract is consistent with the paper. There's actually very little more annoying to a reader than having an abstract that talks about things that aren't in the paper. Right? That lack of connection is bad. So in the abstract, this is often used by people to decide, as you found when you're doing your fast browse, right? The abstract dominates. Title and abstract, like if that didn't catch your eye, did you go on? No, that was it, right? So you gotta make this interesting. So you gotta say what's the problem, why you have an interesting solution to a problem, what your solution achieves, and what might follow from the solution. What are the implications? What does this mean? Right? You can have some other things, but those four things should always be somewhere in the abstract. If you don't hit those four things, your abstract's not going to sell. You might need to talk about data and paper, or, comparisons. You might put in some phrases like state of the art and whatever, but all of those are nice to have. These four things you really have to have.
Some people believe that abstracts are the most important part of the paper. Is that right or not?
It depends on how you measure important, but yes. Right? In terms of writing, I may spend longer on an abstract than I do on the related work section. Right? Because you got to, so especially when you have a very tight constraint on the abstract, but it's hard to tell the right story and keep it very focused. Most of the time, it's not that hard, but sometimes it's really hard to make that story really good. So we might spend an hour on that much text, right? And 45 minutes to half an hour on a page of related work, because the related work is, well, part of it is also because if you've done lots of papers in the area, you have paragraphs about related work you get to reuse. So if you're reusing parts of the paper, then it's very fast, but you can never reuse the abstract. It's always new to this paper. So those four sentences, if you actually think about what this talk has had in it, right? The abstract might be that many papers are badly written and hard to understand. It's a pity because good ideas may go unappreciated. Following simple guidelines can dramatically improve the quality of your papers. Your work will be used more, and the feedback you get from others will improve your research. Those are actually the same four sentences. State the problem, state why it's an interesting problem, what your solution achieves, and what follows from your solution. Go back and see those same four things, right? It's not obvious. I'm not saying the problem we address is, right? That's telegraphing what the problem is, right? You can simply state the problem. Many papers are badly written and hard to understand. That's a statement of the problem, right? It's a pity because their good ideas may go unappreciated. Why is it an important problem? Because the ideas are dying in those badly written papers, and so on. So you go through this, okay? So 4 sentences minimum, and then you can embellish it if you have room for other things. The introduction to your paper. You really get in your structure 1 page. Sometimes, depending on the format, you can get a page and a half and get away with it, but really, you should try and get 1 page. Now, that's often really annoying because many papers have taken up half the page at the top, right? So, like, they have the title and the authors and the abstract, and you can't count that first page as a page, right? You don't have to finish on the first page of a 2-column conference paper that took up half the space, but you really don't want to go past page 2. No matter where your intro is, it shouldn't go past page 2. If it's longer than that, shorten it. Why? Because if it's longer than that, people aren't going to finish it. They're going to go on to the second page, and they're going to say, what? It's still not done? I'm done. Okay? So, describe your problem, state your contributions, and really, that's all. Don't go into... So, it's a tricky situation. Sometimes people want to put related work in the intro. Okay? There's a reason we have a section called related work. It doesn't all belong in the intro. The only time to put related work in the intro is when you're going to skip the related work section completely. Then you can have a longer intro that puts your work in context, and maybe it still shouldn't be more than the first page and a second page. And most of the time when I do a 2-page intro, it's because I have this giant figure, which I'll talk about. And when your figure is half a page, it's really hard to fit everything on one page, right? You have a title, abstract, and a figure. That's it. You got to have some text. But, So we'll talk about figure. I don't know if we'll get to figure placement today, but you should place the figure where it is best for your story. Okay? So normally in LaTeX, you actually want to put the reference to the figure before your text. You want to put the figure before your text references it, because LaTeX will float figures forward into the file, but not backwards. It can never put the figure before it's read the figure. And once it's started on a page, so if LaTeX filling out this page and these columns, right, if the figure is read when it's already formatted this part of the page, it can't float it to the top of this, even if here is where I mention it, right? But if I put the LaTeX up here, then it can actually put it at the top of the figure. There'll be some text, and then there'll be fig 2 over here, right? So you often push it up a little into the document so it can float it down, if that was your question. Okay. So anyhow, so you want to keep it to one page. You want to keep an example. My recommendation is the intro should always have an example the audience can relate to. It might not, I mean, this is not a very meaningful example, but you know, it's CS code or whatever. But if you think about success and the acronym we talked about last time, right, you want something that is concrete, that the audience, the reader can tie into. So if they get something in the intro that is concrete, they've bought into it. Now they can sort of follow. It's concrete. They can sort of go along with it. And hopefully it's simple. Okay? It may not be the best example, but it's a simple, concrete example. Okay? And if you can make it so that it's actually unexpected, you've got through the suck part of success. Okay? Write your contributions. And I'll right here. Right? You should have something at the bottom of your right. In this paper, we put our choice on a firmer basis, and then you share your conclusions. My recommendation, it looks like it wastes space, and it actually does increase the amount of space your paper takes up, but your contributions should be a bulleted list in your paper, not a paragraph with numbers 1, 2, and 3 hidden inside of it. It should be a bulleted list. People who are reviewing are so tuned to this, they go looking for that list. Where are the contributions? If they don't see it, maybe there aren't any. Okay, so you want those contributions. But my recommendation is, in fact, when you're writing, you write your contributions early, maybe first, maybe in your abstract, right? You're saying, here is what this paper is going to contribute. Once you've stated those, then go back and write the rest of the introduction. So the introduction is a story that starts big and gets to the conclusions are what you're really adding. And it supports that storyline. It talks about the right characters, the development, whatever risks, so that it becomes interesting. And then you really want this to be the point where the reader says, gosh, if they can really deliver on that, this is going to be exciting. I better read this whole paper, right? Because that is what you're trying to get them to do. You want them to move from scanning the paper to now it's a critical creative read, right? That's a time commitment adjustment. You want to get them to buy in, okay? Don't leave them wondering during the scan, is this paper important enough? It should be really easy. They're scanning through the paper. This says I have to read the paper, okay? Contributions, when you say them, this is tricky because lots of people don't have contributions. They have a description of what the paper has. And you can have one, maybe two of those, but you want real contributions. Contributions need to be something that's refutable, okay? We describe the whiz-waz system. It's really cool. Sorry? That's not a contribution, right? We give the syntax and semantics of a language that supports concurrent processes, section 3, its innovative features are, whatever, right? Now you've said something they can verify. it's actually useful sometimes to actually give them a section number. Okay, I said last time, right, you don't want to have a table of contents as a paragraph, but having forward references to the sections that show your contributions is perfectly fine, because what you're really saying is, if this is the contribution you need, go to section 3. If this is the contribution you need, go to section 4. You don't present it as, in section 4 we do this. You say, here's the contribution, see section whatever for details. Okay? We study its properties, right? No. We prove the type system just is sound and the type checking is dedicated, decidable, right? You're going to say, here's what we actually do, not that we study its properties. It's true you study its properties, but that doesn't help the reader understand if those properties are worth looking at. We have used the WizWaz system in practice, right? You know, we built the system, we implemented it with a text editor. The version is half the length of the Java version. So we actually did it, we experimented with 500 subjects, whatever. Get into how you actually validated that it was useful, not that we have used it. Okay, so those would be conclusions. Okay, and no matter what you did, don't have the rest of this paper is structured as follows. That is a sign you did not have enough content to fill the paper. Remove it and add a figure. You don't have to write any more words. You can just add a good figure, and that'll actually make up for all the space, and probably more. Okay. As I said, use forward references in the introduction, in your contributions that can go forward, but you don't have to know it. You know what? People have read these research papers so often, they know the order they're going to be in. As I said, I've tried this. Better to not put the related work here and put it at the bottom. But be careful. Talk to your advisor. Look at the papers in the venue you're looking at. If you can find no papers that put related work last, it's probably too dangerous for that field for you to do this among your early papers. You can try it later after you get some experience, and it won't matter so much that you get rejected because people say there's no comparison to related work. Okay? And absolutely only do that in a place where you have a chance to give author feedback and rebut the reviewers. So when the reviewers say there's no related work, you can say, yes, there was. It was right here. It's page 3, you know, whatever. And the other reviewers might get them to change their mind. If you don't have that, you just take too many risks. Okay, so why do you think I don't want related work after introduction, despite the fact that you see it so often? They might dismiss the paper too early, right? They were excited. They were reading about your problem and your idea, and now it's like, oh, look, here's a literature search. How many of you, when you're doing your creative reads, skipped the related work and went right to the next section? Most of you, okay? So why, if that's what we're going to do, are we going to put this related work between your reader and your idea, right? It's actually, let them buy into your idea, get into it, and then you can have related work later. It actually makes it easier to explain. It's a struggle sometimes writing the related work sections to say, here's this paper, and here's how it's different from ours, but I haven't told you what ours is yet. I mean, it's really hard to make that comparison. It's much easier to do that after you've introduced all of your stuff, and then you can relate it much more easily. So it's nice, but in most of our fields, in my fields, it's hard. Right? You can do this at NIPS. You can't do it at CVPR. It's getting to the point where you might be able to, but it's tough. And then like ICML, never. Yeah, so when I tried this for ICML and for one of the NIPS papers where we've done it, you have in the intro, like you take the 1 or 2 most related pieces of work and you include them in the intro, right? This problem was introduced by these people. That's really the way, because they did introduce the problem. We're just going to make a better solution, right? And we discuss other related stuffs in section whatever, right? The important is that we significantly advance beyond the accuracy of their solution, whatever. So you can put a few references in the intro and a forward reference, then it's okay. But that still presumes people read it, right? Okay, so as I said, the reader really doesn't understand your problem yet. Depends on how much you put in the intro. So your carefully trimmed descriptions of the various technical trade-offs is largely incomprehensible. They can't really understand your related work section. Describing the alternatives between the reader and gets between the reader and your idea, and in fact, they might actually think your idea is so derivative because you had a short description and you now have a hard time differentiating it. You risk the risk that they think your idea is not new. And then finally, as I said, readers skip it and come back later anyhow, right? So you might as well just put it later. But we'll see. Okay, so the problem, right? Presenting the idea. It's really important, these three together, the problem, the approach, the details, and whether or not you call it the approach, the methods, whatever, those are really the core of the paper. Okay, when you're presenting the idea, and so the introduction introduced the problem. Very often when you have a section called the problem, it's more like formalizing the problem, right? The introduction was a vague, very broad view of it. Now I'm going to make it very formal. This is true, especially in our fields where we have machine learning and vision stuff, where we're trying to be more precise about here's what we're assuming about the world, here's the inputs, here's what we're going to do. It's true in some cyber places where you assume here's the formal models of attack and whatever else is going to go along with it. So you want to choose what that is. And be careful when you're presenting the idea not to get really deep into the terminology of the subfield as you view it, right? So, considering a bifurcated semi-lattice D over a hypermodulated signature S proposed, whatever, okay, yeah, it might sound impressive, and there might be 3 people in the world who are impressed because that's exactly what the way to describe the problem. You got to get them into it gently, right? You got to have, here's the sort of general introduction, and here's how you have the motivation for the problem, which might be in the intro. Now you're going to sort of formalize it, describe the formality informally, and then have the formal stuff. You got to convey what the idea is before you jump into the mathematical descriptions. How many of you, when you read a paragraph like this, skipped over it and just went on? Okay, right? So think about that and remember how you were as a young reader. If this is something you would have skipped, don't write it that way, right? Because you're just inviting the readers to do what you did as well, skip over it. It's funny, after you get deep in the field, this is what you believe, this is the way you, like, those people sounded so smart, I want to be that way. Not really. They were so smart you skipped their work. That's not really that smart. You want to pull them in. Okay, my recommendation is you explain it as if you were speaking to someone using a whiteboard. Here's the main ideas. Here's a couple of equations to go along with it. Here's a drawing to help explain what's going on. Tell your story that way, especially in your first drafts, right? You can always formalize it a little bit later, but it's hard to get that good flow. This is why I actually do recommend you try and write your paper by talking to it, right? Taking dictation, talking to a microphone, whatever. If you're really comfortable using face your camera and actually whiteboard it out and then turn that into your story to make it work. Once you have that story part, it's okay. Conveying the intuition is the primary, not the secondary goal of your paper. People are not likely, unless they're this weird subtype, to remember the math and the formalisms. They are likely to remember the intuition. And even if they are the subtype that can remember all the math, math is rarely infectious, right? It's not a virus that spreads easily from person to person. You normally have to shove it down students' throat to get it to go, right? You want something that's intuitive, so easy, and so flows off so freely that it spreads quickly among people. That's what you want to get across. Once they have the intuition, he or she can follow the details, but very rarely vice versa. Very rarely can people read the math and say, oh, now I get the idea, right? If you can see the equations and visualize the graph in your head, you're among a very few special people that can do math that way. So even if you skip the details, she'll still take away something valuable from the intuition, which is by far the most thing you want to get out of the paper. So worry about that story from an intuition point of view. And that's why, despite how corny some of the stuff I talked about last week of a character and a struggle and risks and whatever, right? That stuff is what humans remember. They're good at remembering those kinds of story elements put together in the right way. And if you can get that across, your paper will be remembered. Okay? Remember, you're putting the reader first. This is not about your journey to discovery. This is not the 23 things we tried that didn't work, and then finally we got this to work. You may eventually get to tell that story, but not in this paper. This is also why it's very deceiving when you read papers, because it's not how the research was done. No one said, wow, I have this great proof of this idea. Now let's figure out how to implement it and get some intuition and work. Right? Intuition probably came first. Implementation may or may not have come second, but no one thinks it in terms of the proof first, and then a few do, but most people do. Most research is not done the way you read the paper. And you shouldn't write the paper in the way you did the research either. You shouldn't say, well, no one does it that way, I'm going to do it. I've been down this path. I had my first grant proposal rejected for exactly that reason, where I said, here's the 12 problems I'm going to attack. Here's my general way I'm going to do the research. And they're like, no. choose one, tell us a good story about it, and then come back for funding, because we're not going to do this random approach, even though it's what people really do. Okay, so the main payload of your paper, you're going to introduce the problem, your ideas using examples. Only then present the general case. So a good example, it might be 4 or 5 lines, it might be a figure and some text, whatever. You've got to get the reader to understand a simple version of your problem with an example, or they won't understand your problem. Okay? You might worry that, oh, that's too simple. It's not quite as nuanced as my problem. That's okay. That's why they can understand it. Then you can add the nuances later. So you want a really simple example. When we get to the figures, we'll talk about that, right? So you want something that's really simple. If you can give an example, for those dealing with code and whatever, you can give some code examples that are small and done right away. Here's it without optimization. Here's it with optimization. It saves this kind of stuff, right? It doesn't matter that it's not a big example, and the savings of 10% on 4 lines of code is like, so what, right? Then you can always make the example more interesting by saying, well, now imagine those 4 lines of code are in a loop that's executed 1 billion times. 10% times 1 billion now matters, right? So you got to put it in the right context. But your paper has to have the details, the evidence, the experimental section if you're doing experiments, the theory and proof if you're doing a theory paper. There's some section that has lots of details. So in this section, you're going to introduce your claims, and then you're going to provide the evidence to support each of those claims. Good structure would actually be so that I can actually see, here's a claim, here's the data to go with it. Okay? It is tantalizing sometimes to say, okay, here's all the experimental data, and then let's discuss all of it. It is actually better for the reader if you say, here's an experiment, here's what we can conclude from this. Here's another experiment, here's what we can conclude from this, right? Then he or she gets to read them in pieces and doesn't have to remember 4 tables, right, of data before you start the discussion. Put them separately. So it's good to often have in that section subsections. You describe, we're going to go through 4 experiments. Here are our 4 main claims. These are described in these sections. And put them together that way. Now, in the survey paper, by the way, everything I've said so far all applies to your survey paper, right? Nothing I said is about just research papers. The details are where that's a little bit weird. In the details for your survey paper, that's where you're going to take your taxonomy, and now, right, you're going to actually start putting the papers. So you'll have subsections based on the elements in your taxonomy, right? Whatever it is, if it's a matrix, you'll have some discussion of one dimension of the matrix, then some discussion of another dimension, then the other dimension. If it's a tree, you'll describe nodes in the trees. You'll have had a figure, which will be in the intro or the approach, where you've said, here's the big layout. So you've already named those things, and you can even put section numbers in your drawing. Right? And now you're going to get into those sections and go through each of those. So the idea there is to support the claims that there's some relationship among these that is sort of interesting. So the evidence can be analysis is a comparison, which is what you get for papers. Here's the analysis of these papers, here's the comparison, and what's common. Yes?
Is there any way to verify the experiment? Because I found some papers that I tried to verify the experiment that it wasn't running. I didn't know where to find it.
So how do you verify their experiments? I would, if I had to hazard a guess, I would say less than 10% of computer science experiments could ever be verified. So if you put enough effort into them, you could probably get to 10%. Some of the others depended on things they never told you, right? And if they didn't tell you and they actually matter, you can't know it, right? So that's tough. And maybe it's 25, 30%. It's actually getting much better in computer science because more and more people are saying, here's a GitHub with the code and the data. But my students have been working for the last month and a half on replicating somebody's experiments that gave us a GitHub repository and their code and their data, and we still couldn't replicate their papers because the code in GitHub wasn't exactly what was used in the paper. There was missing one command line argument on one place, but how do we know what they did in the paper, right? So, when there's 14 command line arguments you can place in, 2 to the 14th or whatever, 14 factorials, like, it's a ridiculous space to search. We eventually got the author to answer, and now we can replicate his experiment. So the answer is, the only way to really replicate an experiment, even with the author's code, is probably with the author's help. You write to them and you ask them questions, okay? And if they don't answer, then in your paper, you can say, we could not replicate these results. That's the best you can do, right? And you can even tell the authors, right? If we can't, we can't get these to replicate, we'll just say that in our paper, and that sometimes get people to want to reply. The other is sometimes there are other papers that have sort of replicated the results. They normally don't get exactly what was in the paper, right? And sometimes getting exactly in the paper is very hard. We've had our own experiments we can't replicate because we forgot to save the random numbers that go into building the neural networks, right? Because when you build networks, they're randomly initialized. And if you don't use the right random seed, you don't get the same results. Now, you get comparable results, but never exactly the same results, right? So it's a tricky thing. So we got a little bit off. So the structure, as I said, if you really can, try and push your related work to the end. That's where it works better. So many people think the related work section is to make my work look good, and I have to make other people's work look bad. Okay? I got to show I'm better than them. Therefore, I have to make them look bad. That's not what you want to do. Whoops. The truth is, credit is not like money. Giving credit to others does not diminish the credit you get from your paper. In fact, saying they did a good job and I made it even better is way more interesting than saying they did a crappy job and I did a slightly less crappy job, right? Which is the way it will come across. If they did a bad job, you have to then have, if you're saying they did a bad job and they have like 40% performance and you get 48, you must be doing a bad job too, right? If they got 10, you got 90, then you can beat them up a little bit. But in general, just give them, these people have helped. They give you some ideas to get in the way that helps you go through the work, right? Talk about any technical stuff, but don't beat them up. Why not? Besides the fact that it's just not good karma, remember, they might be your reviewers, right? So anything you say bad about them might not sit with them as a reviewer. And it's tough when you're a reviewer and you get people, I dealt with this in a recent review, where they said, we didn't even cite this paper because it was so bad, right? It's like, okay, well, sorry, they cited the paper, but we didn't even discuss it because it was so bad. They just cited it, and it's like there's no reference going on to it. Okay, in the paper, right? Don't say things you don't believe, right? So, like, if the paper was interesting, you can say in their interesting paper, right? If they said, right, in this paper they had this crappy security idea, right? Don't present it that way. You can turn around and make it pretty positive. Also, it's tricky. You want to acknowledge the weaknesses in your approach. This is actually common in my field. Papers that don't talk at all about their weaknesses are often beat up by reviewers because now you're going to make me as a reviewer think hard about what is your weakness. So you should think about, here is my biggest weakness, and see it's not that bad. If you can forgive me for not being able to solve these 5 examples, and there are 5 examples that I fail on, maybe I can forgive your, if you forgive me for that, my paper's okay. But if you don't show me any failures and your system's only at 68% accurate, then do I know that you're failing on hard things, or maybe they're all easy things and it's whatever. So, so as I said, failing to cite credit can kill your paper. If you imply an idea is yours and not theirs, that's it. You're done. So either you don't know it's an old idea, that's bad, or you do know and you're pretending it's yours, and that's really bad, right? So it's really important that your literature search finds the most related papers, okay? And they may not describe it in the same terms you do, which is part of why we did the browsing exercise, because you'll quickly figure out, here is something. At a minimum, one of the things you should do, take all the papers you're citing that are more than a year old and look quickly through the papers that cite them to say, could one of these people, because if you're citing them because they're related to your problem, hopefully somebody else who's also solving something related to your problem also looked at those papers, right? That gives you a quick reassurance that maybe I just didn't do a bad keyword search. Just browse through those extra papers and make sure they're there. Okay, so conclusions and future work. As I said, whether or not you're going to have future work, be brief. Be a conclusion, not a summary. You don't explicitly have to talk about future work. Some risk is that if you do, the reviewers might say, well, if the paper had actually done that, I'd be excited about it, but now they didn't, right? So if you're going to talk about future work, make sure you limit the process about why you didn't get there, right? We did 4,000 hours of experiments. Future work is going to take even more, right? Something like that, so you can limit it somehow. So I already covered a bunch of this stuff because I'm doing this talk out of order, right? So start early. Hastily written papers get rejected. So you want to do many iterations, get them going, use GitHub, collaborate. Reading your papers by as many friendly guinea pigs as possible. I think this was all in my first couple of talks. Yeah, nothing there. So listening to reviewers. It's really important when you get this feedback to treat them with respect. If you submit a paper to a conference and the paper is rejected, those reviews are really a blueprint to what you need to do better. Okay? It is sometimes tough and it's almost like a personal insult. Okay? It's really, really, really important that you step back and say, this is my failure, or this is our failure for our team. We failed to communicate it so these reviewers got it. How do we fix our communication problem so they get it? Okay, it's tempting to want to say reviewer 2 is an idiot. There's actually a whole website about reviewer 2. They're idiots. They don't get the paper. It won't help you very much. Now, if the other reviewer 1 and 3 said this is a great paper, reviewer 2 is an idiot, you can take some solace and sort of dismiss it. But otherwise, there is something about how your paper communicated that didn't get to reviewer 2 to understand. They might have been rushed. They might not speak English as their first language. They might not really understand your field. But that's still partially your problem because your job is to communicate to that broader audience. So if you do take the criticisms positively, we're going to do some in this class. Don't respond, you stupid person. I meant to say X. Fix the paper so that X is apparent. Okay? You will never win an argument with a reviewer by insulting them. Just isn't going to happen, right? They're anonymous. They're on the other side of the table. Thank them for giving you help, giving you feedback. You may or may not agree with them, but don't actively disagree with them unless the other reviewers are already on your side, right? So you can say, like, as reviewer 2 and 3 pointed out, this section is mathematically correct, right? Reviewer 2 didn't explain. Can you please explain why you think it's not, right? Because reviewers say this is just wrong, right? And they don't explain it. So ask them to go into it. Language and style and some other very basic stuff. Submit by the deadline. Know what the deadline is. In what time zone, right? When they say Friday, what the heck does that mean? Friday 9 a.m., Friday 5 p.m., 5 p.m. in whose time zone? London's, ours, Hawaii's, right? There's normally, they're getting better and better at this, but you want to make sure you know those answers. My recommendation is you upload a pretty good draft, which you should have at least 5 hours before the deadline. Upload it so that if something terrible happens and they choose not to give you an extension, or you misunderstood something and you could swear it said Pacific Standard Time, right, or Pacific Daylight Time, and it actually said, right, GMT. Well, actually, you're off by more than 7 hours, so you're in trouble. But if it said, East Coast time or whatever, just upload one early. You will be surprised at the last couple of minutes for a large conference or a large venue, ICSI, right? Their servers grind to a halt when 4,000 papers are being submitted in the last hour. And it's not actually 4,000 papers. It's probably more like 20,000 papers. Because each of those 4,000 authors probably uploads a version, finds a couple more typos, uploads another version, finds a couple more typos, uploads another version, right? And you're going to go through the same process. So upload one early, make sure it's in there, then you can iterate through it as things go on. Keep to whatever stuff they tell you. Whatever the margins are, don't use 6-point font. If they tell you, right, they'll give you a style guide. I'm actually well known in my lab for pushing the limits. I will read the style guide, and it doesn't say anything about the spacing between the header and the first paragraph. Then I feel I can adjust that a little bit. Others say, like AAAI, right, do not use the VSpace command in LaTeX anywhere. Right? So they're very clear about what you can't do. Then I don't do it. Always use a spelling and grammar checker. If your advisor touches the paper, check it. Do not believe your advisor is better than you because, your advisor could, the world just gave them melons, right, as opposed to lemons, right? So, go through that. You want to give your paper a strong visual structure, okay? You want to make sure how to draw pictures and figures, and we'll talk a little bit about those, right? So a paper should look like a paper. Interestingly enough, in CVPR 2015, I think it was, a group of researchers took all of the papers that were submitted to CVPR or were submitted to archive in this computer vision section of archive within 3 weeks of the CVPR deadline, and we said those are all the papers being submitted to CVPR, because that largely is what's going to happen. And then they took the papers that were accepted by CVPR and they turned them into JPEGs that were little less than 1,000 by 800, something like that, whatever the aspect rate, 8 by 11, right? So I guess it's 1,100 by 800, right? You can't read the paper. It's just little blips, right? So it's much less readable than this, okay? And then they took those papers and they ran them through a training algorithm that took the images and then tried to predict whether or not the paper would be accepted from a thumbnail of every page of the paper. They got 70% accuracy in prediction. Right? Papers that, and lots of the papers were not structured well, were largely going to be rejected. And papers that met the formats and looked like all the other papers were more likely. Now, that might actually just be because the people who know what they're doing know to use the format, and those who don't. But it makes it much easier to figure out what's going to happen with the paper. So care about it. Use the active voice, right? Not that it can be seen, we can see. That's a perfectly good royal we. We ran 34 tests. That's not royal. There's only if we have multiple authors. But my recommendation is get a second author. Then you can use we all you want. Don't have these sort of passive things. If you use Grammarly, Grammarly will yell at you for passive. Now, do you think there's any time you do want to be passive? Tina, when do you want to be passive? When you're trying to be negative or downplay something, it's not quite negative, but you want to make it seem like it's not that important. Yeah, that group got 86% accurate. Okay, yeah, fine, who cares, right? We got 87% accurate, right? So you alternating passive and active can still be there. So it's not like no passive, just be very careful when you're using it. So that's tricky. There's slightly different styles. I like to actually write in the past tense for the experiments were in the past, and it just makes it easier in my head. I don't think of this week as we did last week, right? Oddly enough, when I'm referring to a paper, the paper I'm referring to is in present tense. So this paper shows, not showed, right? Because the paper still shows it, right? So that makes the tensile things more interesting. Use very simple, direct language. The object under study was displaced horizontally, right, as the ball moved sideways, right, or the ball moved along the x-axis if you have a graph or whatever, right. On an annual basis, yearly, right. Keep things as short as you can. There's a few that are idioms in your subfield. Grammarly does not understand your idioms in your field, right? In security, they will look at things you say and it'll make no sense. The word deep networks, it loves to say like underground cables. It's like, I'm sorry, that's not deep networks, but it'll go through. So if you remember nothing else, you're going to tell a story. We talked about that last class. You're going to identify your key ideas and make them explicit. Make your contribution to those key ideas very explicit. You're going to use examples and follow the rules of the paper. Those are all really key things. Okay. Now, I've got 10 minutes, so I'm not going to make it through all the figures and drawings, but I want to hit the key things because hopefully you'll think about these. So first of all, figures and drawings should tell your story, right? As I said multiple times already, right? I believe in the comic book version of your paper. Figures and captions should tell the entire story. This is tricky, especially when you get people who won't let you have long captions. There's some journals where, say, captions can only have 100 characters, right? Figure 4, right? A figure, see the text, right? I don't know. You'll see some of my captions in a couple examples. So by far, the most important figure in your paper is the first figure, which is either a teaser figure or a visual abstract. And the difference being that a teaser figure hints at something, makes you want to read the paper. A visual abstract actually summarizes the results of the paper. Now, in lots of areas, they call them both teaser figures, but to me, there's actually a distinction between, is my goal that when you read this, you know everything you really need about the paper. So these are some examples from there's actually a link there if you want to talk about how to write a visual abstract. It's a visual summary of the information contained in the abstract. So this paper, right, is talking about 72% of prescribed pills went unused, right? So they have 70, 100 here, we got some green, some black, right? You instantly look at this number. That's not a very deep one. That's a pretty bad one in my view, but it can be. This one is sort of showing that they had this patients undergoing elective colonoscopy. They were randomized, some were here, and they went through this process. And this group had pastoral heart hernias with no mesh infections. Right? So if you understand what that space is about, you can read through that entire figure and get pretty much, here's what the paper's about. I'm going to decide if I'm going to go on, right? It's more useful than just reading a textual abstract for lots of people. Okay, so I'm going to do through a couple examples of these. So a sample, this is what I call an example teaser figure. This is from one of our papers. This is a simple example. The idea with this kind of teaser is to get the reader to think they understand the idea and why it's valuable. Right? There's no real meaningful data here. It is a simple toy example. In this case, there are like a couple of classes, and then I'm showing the surfaces that are being computed, and we talk about how can it handle these unknown points, and it's trying to get the reader to understand both the problem and a little bit about what our solution is. But there really is no overall set of results. So this is absolutely a teaser figure because it's not everything about the paper. It's really just here's enough to get you to want to keep reading. Okay? And that's useful if you can't come up with a good enough way to describe in that one small figure what's going to happen. Okay? We do some of those in my papers. I would say more than half our papers have a teaser figure. But the next one is still a little bit of a teaser in the sense that it teases with the results, but it doesn't actually explain how this works, right? So this is sort of showing the three competitions in ours, and this is a plot of performance. Okay, in this one figure, and this captured, so this figure in the format of this conference, this is from our NIPS paper, right, which is a single column format paper. This is half a page, right? This one figure. On the other hand, if you read this one figure, you know what the core of the paper is about, what we compare it against, and how in this plot here, we are significantly better than the comparisons. These two lines, right, you don't even have to see this very much, right? These two lines up here are us, and that's the competition. Right? We totally destroyed them. It was so far separated. Putting that plot together, people buy into that paper right away. They get, I need to understand how they do this because this looks like it's very significant. And from this side, they actually get, I understand what the idea is. It's a simple idea. I can follow through with it. So those are two examples of teaser figures that make the reader want to keep on going that I believe were effective because those papers were accepted in PAMI and NIPS, and reviewers seem to like the papers. So because of where the time is, I'm not going to actually go through, I'll do next class, some more examples of good and bad figures, but if you're looking for, and I have, I can't find the first two of these, I own them, I don't know where they went, maybe because they happened with what's the next thing. So I have Resonate and Edward's Beautiful Evidence, right? These are books about how to tell good stories with figures, right? So if you want to figure out, like, how do you tell a story with figures? You might actually learn about how to tell a story with figures. So all four of these books are really good versions of this. The library used to have both of the first two, and I had my own copies. I don't know where they are. Resonate and one other book, Slidology, I have in my office. So if you want to borrow one of these, let me know. I'll actually, since I'm going to be gone, I'm going to put them back in the VAST lab. Does everyone know where the VAST lab is? Engineering 149, like right across from the doors. So if you go in, on the far left is a bookshelf. These will be on the top shelf of that bookshelf. You can just go in and borrow them for a little while if you want to read through them. But this might give you some ideas if you're struggling, like, how do I tell a story? Well, after you've read through 40 or 50 different kinds of stories with figures, you start to get ideas of how to tell that. And it's a very important thing. So next class, I will cover some guidelines and examples for how to do some figures, mostly with examples of what not to do, because those are often the things you'll remember. It's like, oh yeah, that's not what I'm supposed to do. So, okay?
How we can make the
Tools. Okay, so let me jump to, oh no. So these slides, by the way, are in Blackboard, or whatever the tool is we're using now, Canvas. So here's a list of some tools for drawing. So I can actually tell you, my number one tool for drawing is not on this list, it's PowerPoint. Okay? If you're really good at PowerPoint, You can draw all kinds of stuff in PowerPoint. If you're not, these are all way better tools, and I still use these tools on a regular basis. So the first two, Matplotlib, are, and I guess you should have put MATLAB on that list. I will update the slides, I'll put MATLAB on that list. These are tools for taking data and making graphs out of it. All of them have decent libraries. These are all free tools, and I forgot to put the /expensive version. So I have Inkscape / Adobe Illustrator. Inkscape is free. It runs on any platform. You can download it. It is a vector graphics drawing package. It's way more complicated to learn than, say, GIMP, which is a draw in an image, but it's also more powerful and makes nicer looking graphics. ImageMagick is another library for playing with images. And then there is, I thought I had, this slide's not properly formatted. There's a couple more tools. They scrolled off the bottom. I forgot to fix it. So I'll update this list of tools. But there's definitely pretty good tools for taking data and converting them into things, and then tools for drawing. But for this week, don't spend any time on tools, right? Hand drawing stuff is where you sketch out your ideas. If you're really good, I can sketch out ideas in PowerPoint faster than I can draw them because my drawing is really bad. Right? I might as well just do it so that people can read it and give me feedback. But you're fine doing hand-drawn drawings for this week's stuff. And then we'll talk more about it next week. Okay?